Hello and welcome to another video. This time I'm just doing a couple more questions which Corrid sent me on basically these are both on roots of polynomials, so I thought I'd do them in the same video once again. It seems sensible. Okay, this first one. This is a bit long, but it's not too bad. Yeah, I think we'd start obviously by thinking, okay, we know the actual cubic, so we're going to go alpha plus beta plus gamma. Well, we just use the standard results. That's minus b over a, which is 4 in this case. Now we'll do the product pairs, alpha beta plus beta gamma plus alpha gamma. Well, that's going to be equal to c over a, so that's 2. And then finally, the product of the roots is just going to be minus d over a, which is 5 here, yeah? And so we get that result, and that's kind of like, okay, very well, kind of nice, yeah? So, yeah, cool, right. So let's actually think about how this is going to work. Let's think, what are we looking at here? Well, suddenly they want a cubic equation with, roots like this, basically. Now, if we're doing roots like that, well, once again, if it's supposed to end up like this, we want to think about the sum, product pairs, and product of the roots, yeah? Now, one of them in particular is very nice, yeah? Let's go straight away to the nicest one, if you like, first. Let's think about if we times all these together. If you times all those together, and actually, this isn't the order I did it in. Maybe I should do the hardest bit first. I don't know. But the easiest one to obtain is if you times all three of these together, you actually get alpha, beta, gamma again, because you're going to get alpha squared, beta squared, gamma squared on the top, divided by alpha, beta, gamma, and the squares are going to cancel, just leaving alpha, beta, gamma. So this should have exactly the same, like a, c over a as this one had. Now you might think, oh, but this is 25 and this is 5. But bear in mind, look, c over a, 25 divided by 5 gives you 5, just like 5 divided by 1 gives you 5. Sorry, minus d over a, I should be saying there. So yeah, that's the easiest one to do. But actually, maybe it's better to start off on the tougher ones. So we'll start just thinking, okay, well, if I want it to have these roots, then the sum of them, which is beta gamma over alpha, plus gamma alpha over beta, plus alpha beta over gamma, well, that should equal minus b over a, shouldn't it? So this is a way of establishing what minus b over a is, because if we now think about how we're going to add these, well, we need a common denominator, so this needs to be multiplied by beta gamma, which actually is what's on the top, so that's going to become beta gamma squared. This needs to be multiplied by alpha gamma, well, that's what it's got on the top, so that's going to become alpha gamma squared, and likewise here we need alpha beta here, so that's going to become alpha beta squared. So you're going to end up with alpha beta squared plus beta gamma squared plus alpha gamma squared all over alpha beta gamma. That should equal your minus b over a. Yeah. Now, the top one we can work out purely because of this formula up here. If we use this formula here, which I'm just going to underline now, I'm just going to use it. I'm going to use the same sense of this formula, but with like two products in it. It is actually quite complicated, this bit. It's the worst bit of the question, really. So I would just put it like this. Consider that alpha beta squared plus beta gamma squared plus alpha gamma squared. According to this result up here, I can just swap alpha with alpha beta, beta with beta gamma, and gamma with gamma alpha, and plug it in over here. So I need these to be adding up to the sum of them all. So alpha beta plus beta gamma plus alpha gamma, all squared, minus 2 times. Now think what happens here. What they're doing is they're doing one root times the other root. So I'm going to do alpha beta, it's not squared, they're doing that one times that one, ignoring the squares. So I'm going to do alpha beta times beta gamma. And that's going to give me alpha beta squared gamma. Plus, and then they do beta gamma, in other words, that one times that one. So I'm going to do beta gamma times alpha gamma. And that's going to give me alpha beta gamma squared. And then lastly, it's going to be the alpha, which is squared because I'm doing that one times that one. So I'm going to have alpha squared beta gamma. Now this factorizes really nicely because firstly I know what alpha beta plus beta gamma plus gamma alpha is. Let's stop writing all these down. That's just 2, yeah? So I'm going to have 2 squared there. And then here, actually they've all got an alpha beta gamma in there, haven't they? So let's factorize that out, leaving just alpha plus beta plus gamma. Now that looks lovely because I know that alpha beta gamma is 5 So I'm going to replace that with 5. And I know that alpha plus beta plus gamma is, I've forgotten already, 4. And so I'm going to have 4 minus 2 times 5 times 4. That's 4 minus 40, so that's minus 36. So what I've discovered here is the top should be minus 36, and I already know the bottom should be 5. And so I've got minus 36 over 5 equals minus b over a. And it seems pretty natural now to say, well, let a equal 5. And this is for your ax cubed plus bx squared plus cx plus d equals 0. This is for that form of the cubic. So if a is 5, b is going to be 36. Is that looking good? Yes, it is. Yeah, it looks looking really good. Now all we've got to do is find the other ones. We've done the sum of the roots. Now we need to do the product pairs, but the product pairs are really easy. Because if you look at the product pairs, what are we going to get? And let's just move the next question I'm going to do down and out of the way. The next question does have a mistake in it. Okay, the product pairs, we're going to be doing that one times that one. Well, they will cancel and they will cancel, leaving just gamma squared. And then we're going to be doing that one times that one, and guess what? That leaves alpha squared. Is it alpha squared? Yeah. And then the last one, we're going to be doing that one times that one, and that leaves beta squared. So the product, the product pairs actually end up with gamma squared plus alpha squared plus beta squared, and that is supposed to be equal to c over a. Yeah. Now didn't we just work out alpha squared plus beta squared plus gamma squared? I'm pretty sure we did. Have we worked that out yet? Maybe not. No, we haven't. So we can just use this result if we want it. Yeah, because we need to work out this gamma squared plus alpha squared plus beta squared. That's that. So in our case, alpha squared plus beta squared plus gamma squared is going to be equal to 4 squared minus 2 times 2. And that's 12. So 12 equals c over a. But remember, a is 5. And so c is going to be 60. Cool. And then lastly, we've got the product, the triple product, which is the easiest bit actually. So if I can just say product here, I'm trying not to rub out this because I really need it in the second question. Okay, when you do the product of all of these, just as I explained earlier, as I was trying to convince you earlier, when you times all those together, you end up with alpha squared, beta squared, gamma squared. Oh, that's an alpha alpha, sorry, I always muddle up my alphas and gammas. Over alpha beta gamma, which equals alpha beta gamma. And so that is obviously minus d over a. But it's also, we've already established 5. And a is 5 as well. And so d must be minus 25. And we've done it now. And you can just say, hence, we have 5x cubed plus 36x squared. I can't remember what the other one was. Was it 12? No, 60x and then minus 25. And I haven't made this very clear, I don't think. I hope the examiner will be soft with me. I'm just trying to squeeze it all into the screen, really. But maybe it would have helped if I labelled it really clearly. Help the examiner, sum of roots. Yeah, that's what I should have written first. Sum of roots. Yeah, just to make it really clear, I'm working with the sum here, and I eventually end up with that. Product pairs, underline it, signpost the examiner what you're doing. This is not a good example of what a good answer looks like. Product, and then, final answer. And sorry, I'm kind of like working all over the place. It's just because I've only got so much space on this screen, and it's a bit awkward. Okay, right. And this is the thing, I didn't want to rub out this because let's do another question. Now that was that one, I hope that makes more sense now. It's not too bad actually, it really isn't. That's definitely one which is not unusual. This, particularly towards the end, I don't think they'll be quite as cumbersome as this, and requiring you to know that alpha cubed plus beta cubed plus gamma cubed is that. Now this is in the textbook as a result which you can use without proof and just learn. I haven't learnt this, I'll be honest with you. I mean, isn't this what the formula book's for? Why wouldn't they put that in a formula book? Like, I don't understand why they put things like, I don't know, tan differentiates to sec squared. That's something you should learn. But this, it takes a while deriving it. You could burn through 10 minutes deriving this. You really could. And you haven't got 10 minutes to spare in the exam. So my advice to you would be learn this result. It really would. Okay, let's do this question then. So first we've got to show that alpha squared plus beta squared plus gamma squared is 4. Well, let's just quickly write down first the rule. So alpha plus beta plus gamma is going to be equal to minus 2, because it's minus 2 over 1. Alpha beta plus beta gamma plus alpha gamma is equal to 0 divided by 1, which is 0. And then finally, alpha beta gamma is going to be equal to minus d over a, which is going to be minus k in this case. Yeah. So we've got those in the general form for that cubic. Now we've got to show these two results are true. Okay, the first one's no problem because we're just going to use the formula that we were using before, that one underlined in green. And so I'm just going to say like this for a part 1. Alpha squared plus beta squared plus gamma squared equals alpha plus beta plus gamma all squared minus 2 times by the product pairs, alpha beta plus beta gamma plus alpha gamma. Okay, and what does that come to? That comes to minus 2 all squared, which is 4, minus 2 times 0, and so it equals 4 as required. Done. Part 2. Okay, if you just use the formula without proof, then this is easy. Yeah, you try and prove it, and it's a right old pain. Okay, so alpha cubed plus beta cubed plus gamma cubed equals alpha plus beta plus gamma all cubed, so that's minus 2 cubed, minus 3 times. Okay, we've got minus 2, but then we're going to be timesing it by 0, so that just kind of nukes that term. And then we're going to have minus 3 times by k. And that comes to minus 8 minus 3k. I suspect that Madasmaths, looking at the mark that was worth, wanted you to prove that result, to derive that result. I may well do a video deriving the more awkward ones because I quite like to for myself in some ways, just to remind me what the best way is of deducing that. I suspect that the best way of doing it would be to just work with alpha plus beta all cubed and do it like that. Now, for the next part, yeah, the first thing I realised after solving it was either I've made a mistake or the question's made a mistake, and after using my calculator I realised the question had made a mistake. But let me show you what I did. So I'm trying to find alpha to the 4 plus beta to the 4 plus gamma to the 4. Well, the first thing I did was I spent 15 minutes trying to work this out, not doing it the most efficient way. So I'd just like to point out, you know, like we all do silly things sometimes and take a route to the answer which is definitely the slow way of doing it, going into the mathematical fog. I think I probably could have got there, but it just wasn't. I basically gave up in the end and thought, well, there's another way. And on the way to getting a coffee, up the stairs, as I was walking up the stairs in the school, I thought, why don't I try this? Yeah, if I do that, firstly I can work out alpha squared plus beta squared plus gamma squared. Well, I don't even have to actually because I've already got it, but I know that when I expand this out, yeah, I'm definitely going to end up with an alpha to the 4 plus beta to the 4 plus gamma to the 4. And what's more, I can also just use the result from earlier, can't I? Like of you know, this basically rearranged. Where is it? This green one rearranged. I can think of the alpha beta gamma here as alpha squared beta squared gamma squared, and therefore replace all alphas, betas, gammas in the rest of this equation with alpha squareds, beta squareds and gamma squareds. So I'm going to end up with alpha to the 4 there, beta to the 4 there, gamma to the 4 there, plus 2 times alpha beta all squared, beta gamma all squared, gamma alpha all squared. Yeah, do you see what I mean? That's basically what I'm going to do. It's a cheeky move. So here we go. Let's just actually do it. In fact, I'll just write down that result, that green result again, just so you can see what I'm doing. You know, I'm just going to say note alpha squared plus beta squared plus gamma squared is alpha plus beta plus gamma all squared minus 2 times alpha beta plus beta gamma plus alpha gamma. Yeah, so as I know that, I can just replace that with alpha squared, that with beta squared, that with gamma squared throughout the whole equation. Yeah, so this should be equal to, if I'm looking at it as this bit, alpha to the 4 plus beta to the 4 plus gamma to the 4, and please feel free to just multiply it out with a big grid or something like that, plus 2 times, now be careful here, I think we're going to have alpha beta all squared plus beta gamma all squared plus alpha gamma all squared. Yeah, okay, All well and good. Yeah. Now let's see what we get with this. Now we know on the left hand side that this, we know that this bit equals 4. Yeah. We also know that this bit is going to be equal to 4 squared. Yeah, so we get 16 equals 4 plus 2 times. Now, let's have a look at this. Have we already got this in some sense? I think we have. Did I multiply it out differently last time? That's what I'm just suddenly thinking. Or no, I think... Yeah, no, I think this is... Yeah, no, this is cool. Okay, so what about the product pairs here? All squared, the squares of the product pairs. I think we did something with this in the earlier part of the question, actually, didn't we? Of a different question. We were working with this. Yeah, look, here it is up here. Consider that alpha beta squared plus beta gamma. Yeah, basically I've just swapped it all in once again. So I'm using this, that kind of result, but this time I'm annoyed that I've rubbed it out now again then. So what I'm going to do is I'm going to point out that, let me write it down yet again, alpha squared plus beta squared plus gamma squared is alpha plus beta plus gamma all squared minus 2 lots of alpha beta plus beta gamma. There's never enough space on the screen or on the paper when you're doing these questions. It's so algebra intensive. Beta gamma plus alpha gamma. Yeah. Now what I'm going to do basically is I'm going to replace in here alpha with alpha beta, beta with beta gamma, and gamma with gamma alpha. So that's going to happen throughout the equation, and so I can see that this is the same as, okay, right, alpha beta plus beta gamma plus alpha gamma squared minus 2 times. Now this time we're going to be multiplying that one by that one, so we're going to have that same situation again of alpha beta squared gamma plus alpha beta gamma squared plus alpha squared beta gamma. Yeah. Okay, so quite complicated here. So we're going to get 16 equals 4 plus 2 times, but I think we're now in a position where we can just sub in, because we know that the sum of those is 0, I believe. If we go back to the start, that's 0. And then we're going to get minus 2 times. Now remember, we can take an alpha beta gamma out of that and leave an alpha plus beta plus gamma in there. And so alpha beta gamma, I can't remember, was it k or minus k? It's minus k, and the sum is minus 2. So we're going to have 16 equals 4 plus 2 times minus 2 times minus k times minus 2. And that's obviously minus 4k times by 2 is minus 8k. So I get 16 equals 4 minus 8k. And I end up with, rather disturbing, 12 equals minus 8k, and k equals minus 1.5. And you immediately think, oh, I've done it wrong. Yeah? No, you haven't. Because I couldn't see my mistake. I thought, I'm not getting k as minus 1 here. And I suddenly thought, well, hang on, my calculator, if I plug in k is minus 1 into there, yeah, my calculator will solve that equation. So that's what I did. And I got z cubed plus 2z squared, plus 0z if you like, minus 1 equals 0. And my calculator told me that the roots to that were minus 1.618, minus 1, and 0.618. Now I immediately looked at these and thought, that's got to be the golden ratio. It has to be the golden ratio, and I believe it is. So if you do root 5 minus, let's do root 5 plus 1 made negative. I mean, it's the same as root 5 minus root 5 minus 1 over 2. I think it will give you this, and I think this one, I mean, minus 1 is obviously fine, and I think this one is just root 5 minus 1 over 2. Yeah, those are the roots to this equation. They really are. And if you plug them in afterwards to check that they satisfy the equation, you'll see that they satisfy them. And so what I did next was I was like, well, okay, let's try doing this to the power 4 plus this one to the power 4 plus this one to the power 4. And I didn't get 4, I got 8. Yeah, so I think the question's wrong there. That must equal 8. And the answers on the website are wrong as well. You know, they're wrong there on Madasmaths, I'm afraid. That's very rare that they seem to make a mistake, but this one I'm certain of it because my calculator told me. That's why I'm certain of it. So yeah, there's a mistake in the question there. Now, if we instead assume this is 8 and k does equal -1, it's dead easy then to determine the value of this, particularly now with a calculator, because once you've got k is -1, you've got all the roots. You can just do that to the power of 5 plus that to the power of 5 plus that to the power of 5. And if memory serve, I think it comes to -10. But there is a mistake in that question. That's how I would have done it personally. They've got a really weird way of doing it on the website as well, but honestly, this way is absolutely fine for finding alpha to the power of 4 plus beta to the power of 4 plus gamma to the power of 4. And please feel free on your calculators to check it yourselves. Plug that in as -1. You can find the roots of that, or your calculator can, and you'll find that one works fine. You'll find this one works fine. You know, it gives you, what is it, -8 plus 3, which is -5. But then this one should equal 8. So, yeah, there's a problem with that question. So, yeah, don't worry about it too much. They've made a mistake. Okay, hope that was useful for you, whoever's watching, Corriday, and anybody else. And, yeah, keep up the hard work. Bye-bye.